G'day YouTube. Have you ever wondered about the smell of the rain? Herewith, from page 52, New Scientist magazine, 29 June 2019. Almost the last word on the back pages. Storm warning. What causes the fresh smell we experience just before the onset of a storm or shower of rain, which is especially noticeable after an extended dry spell? Answer from Chris Daniel. Lalan San Fafraid Glan, Conwy, UK. Let me guess, Wales? The smell is probably ozone, which typically has a sweet pungent aroma. In stormy weather, lightning splits atmospheric nitrogen and oxygen molecules. These can then combine to form nitric oxide, which, with further reactions, forms ozone. This is then carried downwind ahead of the rain with its characteristic fresh scent. Closer by, there is a deliciously earthy smell that is associated with light rain following a prolonged dry period. This is due to a combination of compounds in the soil that are produced by plants and bacteria. In long dry stretches, plants produce a growth-inhibiting fatty acid that was given the name petrichor in the 1960s, derived from petra, the Greek word for rock, and ichor, the golden blood of the gods in Greek mythology. This aromatic compound is released from the soil and is the source of the earthy smell following rain. Another part of the scent comes from the actinomycete bacteria that are often found in soil. In dry periods, they form spores and in doing so produce a molecule called geosmin, or geosmin, perhaps, derived from the Greek words for earth and smell. It is said to be detectable by humans in concentrations as low as 5 parts per trillion. The mechanism for the release of these chemicals into the air was only described as recently as 2015, when it was observed that bubbles of air that are trapped under a raindrop, landing on a porous surface, collect the spores and oils, then transport them up through the raindrop, releasing them into the air as aerosols. The smell is most intense during light rain with little wind. If the rain is too heavy, the aerosols are washed out of the air and the smell is lost. Bit of a segue there in my personal speculation. The way that would have to be accounted for would be if there's some kind of a surfactant on the outside of the spores. So when the raindrop lands on them, the spores are able to alter the surface tension of the water. Then they get in, they migrate up through the droplet. When they get to the bottom of the meniscus, their surfactant does its stuff again, and the surface tension of the water is dramatically suddenly lowered, causing the droplet to burst into an aerosol. Just a guess. Returning to the story, my father, an airline pilot in Australia in the 1940s, once spotted an enormous population of birds in Lake Eyre, South Australia. The area is completely dry and barren for most of the year, but unseasonal rains had covered the region like an inland sea. He marvelled at how the birds could have known to travel there from hundreds of kilometres away. I now wonder if the same chemical signals that humans appreciate also attract birds and other wildlife that associate the scent with food and survival. Well, it seems like a pretty good speculation to me, as guesses go. But how would you know? The wildlife declines to say either way. Warbles on a lot to YouTube. Ciao. Arr.